So this question is question 3 from activity 3. I know that I've also had some questions for this, so very similar to activity 2, except it's not a binomial distribution. And again, very similar to activity 1, except it's not a uniform distribution. It's a new type of distribution. Hopefully you've read through the content and went through that, and if that's still not helpful, hopefully this video will help a little bit. So we've got a group of 15 students and 3 teachers. If 4 members of the group are randomly chosen to go on a retreat, determine the probability of selecting 3 students. So in this case, we have to think about more than just combinations, okay? It cannot just be choose 3 students of 15 students. We actually have to go through a little bit of work. So it's very similar to what we did prior to this unit in probability. So I'll kind of go through both to show you how this works. So because we're doing the probability and we know that we're in hypergeometric distributions, we know that we're going to use the formula for hypergeometric distributions. But why? So the reason we're using hypergeometric in this case is because there's a success or there's a failure. You're either going to select 3 students or you're not going to select a student. Now that's also a characteristic of the binomial distribution. So how do you know which is which? So the reason or the way you do find out is if it's an independent event, we know that it's a binomial distribution, but if it's a dependent event, we now know that it's a hypergeometric situation. So in this case, there's still a probability of success, which would be selecting a student or not, or there's a selection or a probability, of failure. So it satisfies that condition, but it also satisfies the condition that this is a dependent situation. So dependent variable or factors means that if you pick one student, it'll affect all the other number of students that are left over, or the probability of getting that one student. So because you're not picking the student and then putting them back in to pick them again, which wouldn't really make sense, when you pick a student to go into a committee, you do not put them back to pick them again. It doesn't even make sense. It's hard to even explain. So because this is dependent, we're going to use the formula for hypergeometric distribution. And this is what that formula looks like. It's not an easy formula to remember, that's for sure. But you have to understand what each variable represents. X is an easy one. N is relatively easy to remember, but I find that between R and A, those are 2 that you kind of have to study and remember what they are. So A is the number of successes in the population, okay? R is the number of dependent trials. So when we're doing this, you have to remember that those letters represent specific numbers. Okay, so when doing this, we're just gonna do the probability that our random variable equals 3. Because if we go up here, it says determine the probability of selecting 3 students. I'm going to define my random variable. My random variable x equals number of students, because that's what we're looking for. We're not looking for the number of teachers. We're looking for the number of students. So remember to define that random variable, since it makes it a little bit easier. So now since we're looking for 3 students, we're going to put capital X equals 3. So here's to figure out the rest of it. So A is the number of successes in the population. So the number of successes in the population would be how many students do you have in total. So you have 15 students in total. So that's your A value. Okay, so maybe I'll label my A value right up here. My X value is just the number of successes. So 15 is the population, number of successes in the population, so all students. But X is the number of successes that we specifically want. So in this case, it's 3. So we're going to do 15 choose 3 to start. I'm going to label what the N variable is. N is the population size. So population size is all teachers and all students. So in this case, we have 15 students plus 3 teachers. So N equals 18. We move on to the R value. The R value is the number of dependent trials. So if we're picking 4 members in a group, that means that we'll be doing this 4 times. I think I have all the letters here. Well, X, we define the random variable up here. 1, 2, 3, 4. Yeah, we've got all our variables labeled. So now we can go ahead and do this formula. So N is 18 minus A, which is 15. Don't put a fraction for combinations, please. Don't do that. Okay, that's not how combinations are written. So my R variable is 4 minus my X, which is 3. And all of this is over N, which is 18. Choose R, which is 4. Okay, so if we simplify this a little bit, we're going to have 15, choose 3. 18 minus 15 is 3, choose 1, over 18, choose 4. Now, I find there's an easier way of doing this. If you evaluate this, then you'll get an answer here. Maybe we can just do that real quick. So 18, choose, sorry, not 18, I meant 15. 15, choose 3 equals 455. At the top, there's a multiplication there, and I'll explain why it's multiplication. 3, choose 1 will be 3. And 18, choose 4. Oops. Is 3,060. So if I multiply at the top, I get 455 times 3, which is 1365, which we're going to divide 1365? Yeah, 1365. I wrote that 6 a little bit funny. We're going to divide that by 3,060. And if I do that, I get an answer of 0.45, which is approximately 45%. I'm putting that dot above my equal sign just because I'm rounding my values. So it's a 45% chance of selecting 3 students. So if you recognize that this is a hypergeometric distribution, then it's not a problem for you to just go ahead and use the formula, which I find really confusing for hypergeometric. Now, if you look at it a little bit closer, it's not that confusing. So if you know that you're picking 3 students out of a total of 15 students, then that means that you're picking 1 teacher out of 3. So I find it easier to look at it that way. And when I say I'm picking 3 students, again, if I'm picking 3 students, that means I have to pick 1 teacher because I need 4 on the committee. So those numbers need to add up to the number of people on the committee. The top numbers need to add up to the total number of teachers and students. So it might be a little bit easier to look at it that way. Or you look at it the way you were just doing it prior to this unit. So if you're looking for the probability, don't forget the notation though, the capital X equals 3. I'm looking for 3 students and 1 teacher. Okay, that's basically what that means. And this will be over the probability of all possibilities. So there'd be the probability of selecting 4 out of 18. And if you're doing 4 out of 18, that's just a combinations here. Okay. So remember, probability, you have to divide by the total number of people that you want in your group without any restrictions. So when you're picking 3 students, you're picking 3 students out of 15. And means to multiply. If I'm picking 3 students, it means I have to be picking 1 teacher out of the 3 that are left over. You just don't want to forget this bottom part because that's how you do probability. Okay, so I don't know which method you prefer. You can pick the formula if you do prefer that. Sometimes it's a bit tricky with all these letters, but you can also do it the simpler method as well.